Hello friends, now in this video we will learn Euclid's division lemma, one of the part of chapter number 1, that is real number. Now let's start. Euclid's division lemma. Now what is Euclid's division lemma? Euclid's division lemma says if a and b are any two positive integers, then we get q and r such that a is equal to bq plus r. We already have learned so many divisions. We have learned the division of 3 by 2. We can divide it as 2 ones are 2 and the remainder is 1. We can write it as 3 is equal to 2 multiplied by 1 plus 1. Here 3 is called dividend, 2 is called divisor, 1 is called quotient, and 1 is called remainder. So Euclid's division lemma is nothing but just a is equal to bq plus r. In other words, 3 is equal to 2 multiplied by 1 plus 1. So I can write it as a is equal to b into q plus r. So this a is equal to bq plus r indicates Euclid's division lemma. Now in this chapter we have to learn how to find HCF and LCM using Euclid's division lemma. I am doing the first sum of exercise 1.1. First sum of exercise 1.1. Find HCF and LCM of 135 and 225. Here we can see that 225 is a greater number. So I will take a is equal to 225, a greater number, and b is equal to 135, a smaller number. I am applying the same method. A is equal to bq plus r. So here I will divide a by b. Here I will divide a by b and I will get quotient and remainder. First of all, I will write here 225 and I will divide it with 135. Now friends, 135 ones are 135, and if you do 135 into 2, it will be 217, which is greater than 225. So what I will do, I will multiply 135 with 1 to get 135. Now here I will know 22 minus 13, that will be 90. So this remainder is 90, which is less than 135. So further division is not possible. Now friends, you should remember that this divisor will become a dividend. You should remember that this divisor becomes a dividend for the next step. This is the only thing you should remember, that the divisor will be a dividend for the next step. So I will write 135 here. Now you have to divide as earlier. 90 ones are 90, 90 twos are 180, which is greater than 135. So I will use 90 ones are 90 and the subtraction is 45. Again, you should remember that the divisor will become divisor. You should remember that the divisor will become divisor. So I will write here 90. This 90 I have written here. Now 45 twos are 90 and I get remainder 0. You have to move until you get remainder 0. Okay, you have to move until you get remainder 0. This is our first dividend, this is our second dividend, and this is our third dividend. Now we will use Euclid's division lemma, that is A is equal to BQ plus R. So first I will write 225 is equal to 135 multiplied by 1 plus 90. I have written here 225 is equal to 135 ones are 135 plus 90. Now I will write the dividend number 2. That is 135 is equal to 90 multiplied by 1 plus 45. Now the third one, that is 90 is equal to 45 multiplied by 2 plus remainder 0. Again you should remember, you have to go through until you get remainder 0. Now I got remainder 0. This is the term in which I got remainder 0. The divisor in this term is called HCF. So we can say that the HCF, that is highest common factor for 225 and 135 is 45. You should remember that the divisor for this is considered as HCF. Now to find the LCM, you can use the formula LCM into HCF is equal to A into B. You can use the formula HCF into LCM is equal to A into B. Now LCM that we have to find, so I will write LCM as it is. Instead of HCF, I can write 45. Now what are the values of A? We have 225 and 135. So LCM will be 225 multiplied by 135 upon 45. Now if we cut here 5 9s are, 5 4s are and 5 5s are. Now we can divide 9, so 9 5s are 45. So we get LCM is equal to 135 multiplied by 5. It is 5 5s are 25, carry over 2. 5 3s are 15 plus 2 17, 5 1s are 5 plus 1 6. So I can say that the LCM of A and B is 675. So we can write the answer as HCF of 225 and 135 is equal to 45, and LCM of 225 and 135 will be 675. So in this way we can find HCF and LCM of any two numbers that we can say. Now we will do example 1, that is find HCF of 4052 and 12576. This is an important sum for exam. So greater number, that is 12576, is taken as A, and smaller number 4052 is taken as B. Now what I have to do is 12576 and it is divided by 4052. It is nearly 4000, this is nearly 12,000, so I should multiply it with 3. It is 4052 multiplied by 3. 3 2s are 6, 5 3s are 15, 4 3s are 12. So it is 12156. 7 minus 5, that will be 2, and 5 minus 1, that will be 4. So it will be 420. Now the divisor will become dividend. So it is 4052. This is nearly 420. So this is 420 and this is 4000. So I should multiply it with 9. 9 into 0, 0. 9 2s are 18. 9 4s are 36 plus 1, 37. So it will be 9s are 3, 7, 8, 0. 2 minus 0, it is 2. 15 minus 8, it is 7. 9 minus 7, it is 2. And 3 minus 3, it is 0. Now the divisor will become dividend again. Now 272 ones are 272 and 2s are, it will be greater than 420. Now 10 minus 2, that is 8, 11 minus 7, that is 4, and 3 minus 2, that will be 1. Again 272 will become dividend. Now it is 148, ones are 148 and 2s are, it will be greater than 272. Now 12 minus 8, that is 4. 6 minus 4, that is 2, and 2 minus 1, it is 1. Divided by 148. Again 124, ones are 124. 8 minus 4, it is 4. 4 minus 2, it is 2. So I am writing it here. Now you should remember that the divisor will become dividend. 24 5s are 120. And here we have 24. 4 6 are 24, and here we get 0. So you should remember that you have to move ahead until you get remainder 0. Now I will write all the dividends here. See how I will write it. I will write it using the Euclid's division lemma, which is A is equal to BQ plus R. So first I will write 1, 2, 5, 7, 6. That is equal to 4052 multiplied by 3 plus remainder 420. Now our second dividend, which is 4052, that is equal to 420 into 9 plus 272. Now the third dividend, which is 420, is equal to 272 into 1 plus 148. Now the fourth dividend, which is 272, is equal to 148 into 1 plus 124. Now similarly 148 is equal to 124 into 1 plus 24. Later on 124 is equal to 24 into 5 plus remainder 4, and at last 24 is equal to 4 multiplied by 6 plus 0. So in this step we get remainder 0. For this the divisor is 4. Hence we can say that HCF of 1, 2, 5, 7, 6 and 4052 is 4. So you should remember this. This is important for exam, for 2 marker or 3 marker. Okay? So in this way we can find HCF using Euclid's division lemma. Right? Now we will do third question of the textbook. We will do the third question of the textbook. The question that is, we have to prove that, or we have to show that the odd positive integer is in form 6q plus 1 or 6q plus 3 or 6q plus 5. So question number 3 of exercise 1.1, that is, show that any positive integer is in form 6q plus 1, 6q plus 3 or 6q plus 5. Now in this type of sum in which we have to show that this is an odd number or odd integer in this form or whatever this type of number you have, we know the formula A is equal to BQ plus R. That is the formula which we know, and the condition 0 less than or equal to B less than, 0 less than or equal to R less than B. So this is the condition you should remember. Now here B, that is called the divisor. Here we have 6q plus 1, 6q plus 3 or 6q plus 5. So friends, here we have 6 as divisor. So I will assume that let any positive or integer, or I will assume that any positive integer is a. So I can write a is equal to bq plus r. I can write that a is equal to bq plus r. Now I will assume b as 6. Now you know why I have assumed b as 6, because here we have 6q. So I will take b is equal to 6. So I can say that a is equal to 6q plus r, where 0 less than or equal to r less than 6. So the possible values for r are 0, 1, 2, 3, 4 and 5. Now I will substitute this here. I will have a is equal to 6q plus 0. That is equal to 6q. 6q can be written as 2 into 3q. And as we know that if any number having factor 2, it must be considered that it is a even number. So I can say that this is an even number. Now I will take another remainder, that is 1. A is equal to 6q plus 1. Here we do not have 2 as a factor. In this term we do not have 2 as a factor, so we cannot consider that this is a even number. So I can consider that this is an odd number. Now the next one, that is 2. A is equal to 6q plus 2. I can take common 2 from these two numbers. I have 2 bracket 3q plus 1. Again I have a factor 2. So I can consider it as an even number. Next, a is equal to 6q plus 3. Now I cannot take 2 common from these two numbers. We just have to think about whether we get 2 as a factor or not. So we have 6q plus 3 is an odd number. Later on, a is equal to 6q plus 4. Here I can take 2 common from both. The remaining terms are 3q plus 2. Here we have a factor 2. So it is an even number. And at last, a is equal to 6q plus 5. I do not have 2 as a factor, so I can say that it is an odd number. So I get the answer that any odd number must be in form 6q plus 1, 6q plus 3 or 6q plus 5. So I can write the answer as, therefore, any positive integer is in form 6q plus 1, 6q plus 3 or 6q plus 5. Okay, so any positive odd integer is in form 6q plus 1, 6q plus 3 or 6q plus 5. So in this way we have to do the sum. Now question number 3 of exercise 1.1. That is, an army contingent of 616 members is to march behind 32 members in a parade. The group are to march in the same number of columns, and what is the maximum number of columns in which they can march, right? To find this, we should find HCF of 616 and 32. So in majority cases, whenever you have to find a maximum number, and every time you have to find HCF that is highest common factor, and maximum numbers that is also considered as the highest. So you should remember whenever you are having a maximum number, you have to find HCF. Now again, I will take A is equal to 616, a greater number, B is equal to 32. And as I have done two sums earlier, we will find the division until we get remainder 0. Here 32 ones are 32, 11 minus 2 that is 9, and 5 minus 3 that is 2. And I have obtained 6 here. So now it is 32 9s are 288. So it is 32 9s are 288. Now 16 minus 8 it is 8. 8 minus 8 it is 0. 2 minus 2 it is 0. The divisor will become dividend. 8 4s are 32. So they get remainder 0. So I can write 616 is equal to 32 into 19 plus remainder 8. The second dividend, that is 32, is equal to 8 into 4 plus 0. So I can say that the HCF of 616 and 32 is 8, which means that the maximum number of column will be, we have to find the maximum number of column. So I can write the answer as the maximum number of columns will be 8. So they have to mark in 8 columns. So in this way we can do the sum. Okay? Now the next one. That is question number 4. Now the question number 4, it is square of any positive integer. Show that the square of any positive integer is in form 3m or 3m plus 1 for any integer. Again, we have to use Euclid's division lemma, which says A is equal to BQ plus R. So I will assume that let a number be A. I have taken a positive number as A. Sorry, I will write here a positive number. Let a positive integer is A. Again, you should remember how to write the value of B. You should remember that B wants the answer in form 3m or 3m plus 1. A is equal to BQ plus R, and as you know that B is a coefficient of Q. So here also we should remember that we have to take B as 3 because we want it. If you want here 5m or some else, so you have to take B as 5. But here we want 3, hence I will write that B is equal to 3. Understood how I have taken B as 3? So now I can write A is equal to 3Q plus R. The condition which must satisfy is 0 less than or equal to R less than 3. So we can write the possible values of R are 0, 1 or 2. Now we have to substitute 0, 1 and 2. First we have A is equal to 3Q plus 0, that is equal to 3Q. Now that is equal to, A is equal to 3Q. Now we want a square of that number. So I will take square on both the sides. I have to take square on both the sides. So I can say a square is equal to 9q square. This 9q square can be written as 3 into 3q square. Now I will assume this 3q square as n. So I will get the first one, that a square is equal to 3m. That is, the square of an integer is in form of 3m. Now I will take another remainder. So I will take that a is equal to 3q plus 1. Again I want to square, so I will take square of it. A square is equal to 3q plus 1 whole square. And as we know that the square of a plus b can be written as a square plus 2ab plus b square. I am applying the same formula here. 3q square 2 into 3q into 1 plus 1 square. So I can write it as 9q square plus 6q plus 1. I want the answer in form of 3m or 3m plus 1. Here, these are the two numbers from which I can take 3 common. Okay, I can take 3 common. I want the answer in form of 3m plus 1 or 3m. So that I have taken 3 common. The remaining terms are 3q square plus 2q, and 1 I will write as it is. Again, I can assume that 3q square plus 2q is equal to n. So I can say that the square of this number is in form 3m plus 1. Now the third one, a is equal to 3q plus 2. Now I have taken remainder as 2. Now I am taking square on both the sides. I will have 3q plus 2 whole square. Now again the same formula, 3q whole square 2 into 3q into 2 and plus 2 square. So that will be 9q square, 3 2s are 6 and 6 2s are 12q and plus 4. I want it in form of 3m plus 1. But if I take 3 here, 3 common from this 2, I will have plus 4, which is not equal to 1. So what I will do now, I will split 4. I will split 4 in such a way that I will have 3m plus 1. Okay, so I have split 4 as 3 plus 1. And now from this 3, I will take 3 common, which is 3q square plus 4q plus 1 and then plus 1. By hook or crook, you have to obtain 3m plus 1. So I have split 4 in such a way that I will get plus 1 at last. Again, I will take 3q square plus 4q plus 1 as m, and hence I will have 3m plus 1. So I can write the answer as, so the square of any positive integer is in form 3m or 3m plus 1. Okay, so in this way we can do exercise 1.1. In next lecture we will learn how to find HCF and LCM by prime factorization method. Till then, goodbye.